physically present but mentally absent.
Now see, the first thing that I am going to discuss is the swimmer problem, okay?
Remember the problem?
Now, in case of the swimmer problem, for example, we have a river, fine, which is of width d, okay, and the river is flowing in this direction with some velocity, say Vr, okay, and there is a person, a swimmer, who is on the other side, say at point A, and this guy wants to cross the river and therefore he wants to come out at point B. He wants to cross the river through this point, fine? So if the velocity of the person, keep quiet, if the velocity of the river in still water, or the velocity of the swimmer in still water is V, then if this guy goes straight, he'll not end up at V, right?
Yes, sir.
Rather, he will drift along the river and go somewhere here, correct? Therefore, what he does is, he will, if this is the perpendicular, then he'll jump at some angle to the vertical, okay? So that the river will take him along and therefore he might land somewhere very close to me. Is that fine? Say the velocity of the man in still river is Vm. Okay? Now if you talk about the velocities, the velocity has two components. One is V cosine of theta and this one is V sine of theta. Yes? Now V sine theta technically has to be less, because if V sine theta is more, then he will go here. So he has to let the river help him with the drift. So therefore he is effectively moving towards right, that is the velocity along the x-axis, which is equal to Vr minus V sine theta, is it? So I was saying that the horizontal component of velocity, which the man will still have, will be Vx, that would be equal to Vr minus V sine theta. Okay. This is the velocity due to which the person is going to drift along the river. Is that fine? Now these points which are away, which are in this direction, are actually the upstream points, and all the points which are here are the downstream points. Okay. Is it clear? Now see, the first question that they might ask is, what is the time in which the person can cross the river? Okay. So the time in which the person will definitely cross the river will be given by, yes, time is equal to velocity is equal to distance over time. Yes. So time is equal to distance over velocity. Now the distance that the person effectively will cover will be exactly d upon the velocity. With which velocity will he be able to cross the river?
So will it be root of Vx?
That is no. Don't do that. Don't do that. The velocity with which the person is actually crossing the river is V cos theta. Yes?
Yes.
Because this velocity will help to cross. See, Vx is not going to help. Even this V is not going to help. Understood? This is the velocity of the man in calm, still water. Okay? We are concerned about V cosine of theta. This velocity helps him to go from A to B. Yes or no? So the time he will take will be d upon V cos of theta. Okay?
Yes.
Fine. But this velocity Vx, which is equal to Vr minus V sine theta, is causing some drift. Yes? So that means, for example, the guy jumped straight. Okay? in that situation, the guy will land somewhere here, isn't it? He will not reach point B. He'll go somewhere here, right?
Yes.
So let this be the drift D. Okay. Can you tell me what will be the drift? What will be the equation for the drift? Yes. Drift is velocity times time. What is the velocity in this direction? VR minus V sine theta, where V is the velocity of the man in calm waters, okay? Times the time, yes? What is the time? It is the same time in which he is crossing the river. Because the time he is taking to cross the river will be the same time in which he will drift from B to C, yes?
Yes.
So we have to multiply it by D upon V cos theta. Is that fine?
Yes, sir. Yes.
No problem? Now there are two kinds of questions that he's going to ask. The first is, what is the shortest distance in which he will cross the river? Second is, what is the shortest possible time in which he can cross the river? Okay? All the questions are based on the same concept. If you are able to, relate things to this, all the questions will be solved. Just that you need to know which angle is he asking, which angle is given. Okay? Now, the first thing that I would like to discuss here is the shortest time in which he will cross the river. Shortest time to cross the river. Okay. Now, the shortest time to cross the river, as from the equations we have, the time that we have is d upon v cosine theta. Yes?
Yes.
So the time to cross is d upon v cosine of theta, isn't it?
Yes.
So for this to be the minimum, the denominator has to be maximum, isn't it? So for this, the minimum time to cross the river would be d upon this denominator has to maximize. Now v cannot be maximized; it is already the velocity of the person. Yes. So that means cosine of theta has to maximize. Yes. So when is cos theta maximum? Isn't it?
Yeah.
That means theta is equal to? That means the velocity of the man is perpendicular to the velocity of the river. Is it?
Yes.
Is it?
So sounds correct.
So the velocity of the man is perpendicular to the velocity of the river in that case. Now what happens is, actually it is the drift which will help him to cross. See, when he jumps straight, the river is taking him along, right? So he is not wasting the energy against the flow of the river, yes? Yes or no?
If they are making any problem, just throw them over.
Okay. So now understand. In that situation, should I say the minimum time to cross the river is d upon v? Yes or no?
Yes.
This will be, this is the first thing that you need. Minimum. But in this time, we know that the person is jumping straight. So when he is jumping straight, will there be some drift? Yes? How do you calculate that drift? Drift would be the velocity in that direction times the time, isn't it? Now the velocity in that direction is Vr minus V sine of theta, correct? So should I say the drift in this case would be Vr minus V sine of theta times the time. Yes? The time is what? D upon V, correct? But in this situation, what is the angle? When he is trying to cross the river in the minimum possible time, what is the angle? Zero. So this is? So that means this is 0. So which implies the drift would be equal to the velocity of the river times the distance upon the velocity of the man. Is that fine? In calm waters. This would be the drift. Is it clear? No issues? Yeah. Fine. Also one thing, what is VR? VR is this, VM is this, isn't it? So you can actually substitute the value of tangent of theta or sine of theta or cos of theta. Yes?
Yes, sir.
what is sine of theta from this triangle? Sine of theta, perpendicular upon hypotenuse. So perpendicular is that VR? Yes or no? And hypotenuse is VM. So should I say it is VR upon VM? Yes? So now if you use this concept here, VR upon VM, so should I say this is sine theta?
Yes.
Isn't it?
Yes, sir.
Correct? So you can use that value as well. It depends on whichever way you want to express it. Fine? Okay. So this is the first case when he is asking you to cross the river in the shortest possible time. But then there can be another case. What is the shortest distance in which he will cross the river? Yes? Shortest distance. Shortest distance to cross the river. Shortest distance would be the perpendicular distance, yes? So that means if he has to cross the river through the shortest possible distance, if this man jumps at A, he has to land at point B, yes? In that case, what will be the drift? Drift will be 0. Is it clear? So when drift is 0, when this is 0, it means VR minus V sine theta is 0, yes?
Yes.
So should I say, because this is not going to be 0, correct? So this has to be 0, so that means VR is equal to V sine theta, fine? So in this case, shortest distance, drift will be 0, okay? Because the guy will jump at A and he has to land at point B, fine? He's going to cross the river through this distance. That means his velocity has to be somewhere here, okay? He has to jump in this direction because then only he will be able to reach point B, okay? So when the drift is 0, that means VR minus V sine theta times d upon V cos theta has to be 0, isn't it? For this to be 0, now d is not 0, therefore this has to be 0, yes?
Yes.
So should I say VR minus V sine theta has to be 0? Or should I say VR is equal to V sine theta? Or should I say in that situation VR by V is equal to sine theta? Is it clear? Yes? So can anyone tell me what? So this is the case. So we'll be able to find the angle at which he has to jump so that shortest distance is possible. Okay? But the next part of the same question. Now when he jumps in this direction, so we can find theta. Theta is what? Sine inverse VR upon V. No issues? We know the angle now. Okay? But when he jumps at this angle, he'll still take some time to cross the river, isn't it? Can anyone tell me what will be the time to cross the river now? Time to cross the river, yes. What is the general expression for time? D upon V cos theta, isn't it? But we know sine theta is perpendicular by hypotenuse. Yes? So should I say perpendicular is VR and hypotenuse is V? Can you find the base?
Yes.
Yes, you can. Therefore, base will be equal to V square minus VR square but square root, isn't it?
Yes. Yes.
By the Pythagoras theorem.
Yes.
If you use it here, that means the time in which he will cross the river, when he is crossing the river through the shortest possible distance, will be given by d upon v times, what is cosine of theta? It is square root of v square minus vr whole square. Is it clear? Yes or no? That is it. समझ गया? Base by hypotenuse. Okay, so we forgot the hypotenuse. Yeah, that would cancel. This is cosine of theta. I have not substituted the other value. Cosine of theta is base upon hypotenuse, right? So base is this, and then divided by hypotenuse. So v is here, v and v would cancel. So time to cross the river would be d upon square root of v square minus vr whole square. This is the expression. We forgot to cancel the v.
You won't ask us to derive the expression, right?
No. Now this approach should be applied to all the numericals. All the numericals. Don't memorize the formulas. Approach is to be understood. Because you cannot say he will give the angle with some other direction. We took the angle with the vertical, he can give it with the horizontal. Then which expressions will you use? Everything is reversed, yes? Or the direction of the river is not like this, it is somewhere there. Okay? Or the man is not jumping like this, like what I showed here. The thing is, you have to use the approach that you used here in all the numericals. Fine? Is that fine? Okay. Now there is a question. It was actually mailed to by one of my students. The question is that there is a river which is flowing in this direction at the speed of 3 meters per second. Okay? There is a boat which is at O, and this boat can travel at a speed of 5 meters per second in still water. Okay? And there are 3 points. One is this B, the other one is this A, and the other one is there, say C. Okay. All these points are at 120 meters from O. This is 120. This is also 120. This is also 120. Is that fine? Is it clear? First of all, the river is flowing like this. This is the direction of the river flow. Fine? The boat can travel in calm water at a speed of 5 meters per second. So he has 2 questions. First question that he asks is, what is the shortest possible time for the boat to go from O to C? Shortest possible time. Yes.
Sir, is it 60 seconds?
Yes, how do you do that?
Sir, we take relative velocity. Since the boat will be going towards this and the motion of the river is opposing, we minus it. So 5 minus 3.
So, in which direction should he jump?
Say from O to C, right side.
So, the criteria here, see, understand. The criteria here is he has to go from O to C in shortest possible time. So, technically speaking, if he had to reach point B, he had to jump like here, in this direction. But he has to reach point C. So, in order to reach C in the shortest possible time, what he will do, he'll jump in this direction, yes?
Yeah.
The boat will set its motion along this direction, O to C, yes?
Yes.
In that situation, 3 meters per second of velocity is here, which will not let the boat go up, but then the boat has 5 here. So technically speaking, he has 2 meters per second of speed in this direction, is it?
Yes, sir.
What is the distance? 120 meters. So that means, what that means, the time to cross the river from O, sorry, not to cross, to go from O to C, time to go from O to C would be the distance, which is 120, upon the effective velocity in that direction, which is only 2. So technically it is 60 seconds. Yes, he is correct. Is that fine?
Yes.
The next part. What is the shortest possible time for the boat to go from O to B? O to B. O to B, is there any drift? There isn't. Oh no, there will not be any drift. That means O to B. So he will jump somewhere here, isn't it? Technically he will reach here. Okay. It is the same problem, but in the opposite direction this time. So in that case, we know the time. Yes?
Yeah.
What is the expression for the time? Yes? The time in that case to go from O to B, time to go from O to B. It is the case when there is no drift. It is the case in which there is the shortest possible distance. Yes? In that case, the time is given by, yes, 120, the distance, upon square root of, yes, Vm minus Vr square. We did it. We did it. Vm square minus Vr square, yes? So we can do it here. So that means divided by square root. What is Vm? 5 square minus 3 squares. Is it? So technically in the denominator we have 4. Isn't it? So we have 120 upon 4, which is 30 seconds. So this is time from 0 O to B. Is that fine?
Yes.
Okay, after this, I'm talking about the projectile. Okay, is our class over? So you have to go for some homework. Okay, there are 3 cases. One is the energy of a projectile. The second thing that you have to do is the relative velocity or the relative motion of 2 projectiles. And the third that you will do is the case of complementary angles. Okay, complementary angles, fine. So these, yes.
Motion or velocity?
What?
Relative motion or relative velocity?
Relative motion.
Motion.
Relative motion of 2 projectiles. Case of complementary angles. So these 3 will be your homework. Fine. You can also watch it from my YouTube channel. I have uploaded, I think, these 2 there. But this you have to check from the playlist. Okay. So this is 10 minutes. This is 10 minutes. But because I don't want to now waste time over this. And yes. How many of you are going for JEE? Engineering entrance? How many of you are here for NEET exams? NEET. For NEET, inclined plane is not included. For JEE, you have to go for inclined plane. That would be a projectile, fired like this at some angle theta. Fine, but it is on an inclined plane. Okay. So you need to do this, and this again. You can find it from the playlist, but I don't want to go back and it will take a lot of time. On playlist you go for projectile on an inclined plane, that would do this. However, this and this, all of you are supposed to do this. 10 minutes and maybe 5 minutes, okay? That is the maximum that you have to watch, okay? Thank you so much.
Thank you so much.